Hello everyone, I am Hema Sati Sharma and student we are discussing the chapter time and motion. In our previous lecture we have discussed what is motion and how the time is measured and the unit of time. So in today's lecture we are going to discuss about simple pendulum. So simple pendulum is a device it consists of a small metal ball and this ball is called bob. This metal ball is suspended by a long thread from a rigid support such that the bob is able to freely swing back and forth. So this to and fro motion of the bob or of a simple pendulum is an example of periodic or oscillatory motion. From our previous lecture, we know that periodic motion is a motion in which a body travels equal distances in a fixed interval of time. For example, sunrise to sunrise is a fixed interval of time and a day occurs in that. So day and night are periodic. So Galileo was the first person to study the motion of a pendulum. So here you can see this is how a pendulum look like. So what we were discussing that pendulum contains pendulum consists of a metal ball which is called bob. It is suspended through a rigid support from a long thread. So now you can see through this long thread this bob is able to move back and fro. So this is the periodic or oscillatory motion. So now here you can see how a simple pendulum move. So if you, this is the mean position of the bob and it will go to or 1 to extreme position and then again it will come to the mean position and it will go to the extreme position. So this is the central position. From here this bob will go to this extreme end B, then comes to mean position and then comes to C and then again comes to mean position, or this way this will keep moving. This is the same way you swing a swing in the park, right? So pendulum completes every swing or every oscillation in exactly the same time provided its length should be kept constant. So this, what does this mean? If this length is constant, if this length is not changing, so time taken by this bob to travel this place, to come back, to travel this place, to travel will be same every time. The pendulum is said to have completed one oscillation when it bobs starting from its mean position A, moves to B, to C and back to A. So that means one oscillation is completed when this bob will go to B, go to C and then come back to A. So here you can see this is the mean position. Bob will go to extreme position B, it will come back to A, go to C and again go back to A. This is called one oscillation. The pendulum also completes one oscillation when its bob moves from one extreme position B to another extreme position C and come back to B. So how is this occur? B to C and then to B. So now there are two cases. First, bob was on the mean position. So mean position say it will go to one extreme, other extreme, then wapas mean position. This is one oscillation. Or the second case may be one extreme position to another extreme position, then to first extreme position. This is also one oscillation. So there are, in two ways there can be one oscillation completed. So now the time period which is taken by the pendulum to complete one oscillation is called the time period. So moving from one extreme position to the other extreme position and to the first extreme position back, time taken for this one oscillation will be called time period. And the time period of a pendulum is dependent upon the length of the thread from which the metal is suspended. So the length of the pendulum is the length of the thread from the point of suspension to the center of the bob. This we have seen in the picture also. The maximum displacement of the bob from its mean position is called the amplitude of the pendulum. So what is the maximum displacement? That means from mean to one extreme position. So displacement AB or AC is called the amplitude of the pendulum. So here in this, from this diagram, you can see that A to C. So this distance in one direction only, this distance is called displacement. And this distance will be equal to this distance. So AB or AC, both are amplitude. So AC is also amplitude, AB is also amplitude, and they both of them are equal. Now we will take the example. If a pendulum is making 40 oscillation in 4 seconds, find its time period. So if a pendulum is making 40 oscillation in 4 seconds, so first we'll see what is the definition of time period. Time period means the time taken for one oscillation. So if 4 seconds, if it is taking 4 seconds for 40 oscillations, that means it will take 4 by 40, that means 1 second, 1/10 of 1 second. Next is we have to calculate the time period of a simple pendulum if it takes 72 seconds to complete 24 oscillations. So here it is taking 24 oscillation in 72 seconds. So one oscillation, how many time, in what time it will take one oscillation? So time period is time taken for number of oscillation upon number of oscillations. Number of oscillations are 24 and time taken is 72. So time period will be 3 seconds. In our next lecture, we will be discussing about the speed. Thank you so much.